Hi class, this is Professor King. Welcome to the help file for the Chapter 4 and 9 lab for BA 242. In this lab, we're going to talk about forming data tables in Excel, what they're useful for, what they do, and how you can effectively use them to create easy-to-use formatting and such things as you work in Excel files. We're also going to look at our VLOOKUP and HLOOKUP again. This time, in our VLOOKUP and our HLOOKUP, we're going to be doing the same lookups that we did in a previous lab, where we look up favorite animal, city, and number of dependents based upon the names of people in this list. Except this time, we'll notice that the lookup values are on a different tab. So we're going to work on tab management, as well as revisiting the concepts for these VLOOKUPs and HLOOKUPs. So a little more challenging than before, and you start to understand why we would want to use a VLOOKUP and HLOOKUP. Before, you'll remember that our data was approximately here and approximately here. So it didn't make a whole lot of sense to be using these lookups when we could just use our eyes to figure out the answers to the questions. But when it's on a different tab, it becomes more difficult to do with the human eye, and so it's nice to have these Excel functions that will help us. So we're going to work on that again as well. Additionally, I've told you a couple of times now that I'm really keen on payment functions because they're very useful to you as you go through life. So we're going to figure out payments on this tab as well, but what I also want you to realize is you may see something like this in real life or on an exam in this class situation where you're required to fill out this is called an amortization table. So this entire loan amortization table, or this isn't really an amortization table because the payment amount changes, but it looks like one. So any table with all these varying values. So eventually you'll have to create one of these of your own, and this one is trying to help us figure out if our interest rates for monthly payments are different and our borrowed amount, our present values are different. What are the options that we're facing? So I'm going to teach you how to use what's called mixed referencing, not absolute referencing, not relative referencing, but mixed referencing to be able to put a formula in this one cell and then be able to drag it across and down and fill up this whole table so that you won't be wasting time on an exam or in any other workbook or solving a business problem going and typing formulas in multiple times. You can have Excel do all the work for you. So we'll talk about that. Lastly, we're going to talk about this tab over here based on commissions, and we're going to talk about the business logic of commissions, and we're going to figure out which of these representatives earns what amount of commission. Again, I know, guys, there are 6 of these. We could probably figure this out with a calculator, but in real life, they would extend way far down past 6 rows, but that's all you need to be able to test your skills. So we're going to go through this and work at it one thing at a time. So first, let's look at this data table. Up until this point, you probably think about Excel as tables in general, and you think of Excel worksheets as tables. Well, really, they aren't data tables. They're just data once it's in Excel or in any spreadsheet modeling software. In order for it to be a table, and I use table in air quotes, we have to do some formatting to it and allow it to have different functionality. So right now we have this data in rows A through E that have year, quarter, month, room type, revenue, so on and so forth. And we can scroll down to the bottom. There's 48 rows of data and headers, and we realize that we could do a lot of things. We could sort, we could filter, we could add all of these numbers up, we could do a lot of things, averages, so on and so forth. But we're going to create what we call a data table and allow Excel to do that for us. The easiest way is to click somewhere inside the data, and remember, Excel is going to grab all the contiguous data or the data that touches each other. So you click somewhere inside the data, and you're going to go up to the Home tab on your ribbon. You're going to go over here to Format as Table. Format as Table appears in the Home tab of the ribbon. Alternatively, you can go to Insert and click Table. There's multiple ways to skin a cat, as we say in Excel, so you can get there however you want to. I don't care. I personally like this Format as a Table option because the instructions ask us to create a blue table, and all of these blue styles are right here for my liking. So you just randomly pick a blue one, and I haven't told you which blue one to pick, and normally I won't. I'll just give you some suggestion of what color to make it. Once you click on a style, it's going to say where's the data for your table. Excel, again, is going to select all the contiguous data. So all the data that touches each other, it is going to select for your table. You then have that next option with the checkbox that says my table has headers. This is really important to know if your table has headers or not. If your table does not have headers, Excel will try to put them in for you. It will try to name your data for you, but if you've already decided what your headers should be, and they're already in your worksheet, please make sure that the box is checked for my table has headers. This one does. You see them across the top here. Year, quarter, month, room type, revenue. Those are what we call headers for each column of data. So we already have those. We'll leave that box checked and click OK. You'll notice when I do that, all of a sudden this turns blue. And visually, that's probably what you see first. You see that my table is blue. I can still go up here, change the way my table looks. If I decide I don't like that blue one, I can choose another one. I get a lot of options when my table or my table design tab is present. You'll also notice when I create a data table, I automatically have the option to filter by all of these different headings. I can filter this data by anything that I want to filter it by. Those are automatically included. You'll notice over here as I'm on the table or the table design tab, if you're on a PC, I'm obviously not on a PC, but if you are, you'll see table design tab. But over here in the left-hand portion of the ribbon, you have what's called a table name. Your instructions say to rename the table 2 rooms 1516. So we'll rename it 2 rooms 1516. We'll rename it with no spaces because, as we've learned in class, Excel gets really wonky when you try to add spaces to names. It doesn't like it. It'll take it for some things. It won't take it for other things. It's just easier if we don't use spaces. So you'll notice now if I click off of the table, the tab for table or table design goes away. If you lose it, just simply click back in the table, but you'll notice my table name remains. Why would I want to name a table? Well, you know the answer to this already. I would want to name a table or any other range of data. I can name any range of data that I want to. I'm going to name it because I might want to reference it in the lookup, for example. If I wanted to create a VLOOKUP based on this table, instead of typing A1 to E49 or wherever this table goes down to, I could just name in my argument, I could just put 2 rooms 1516 and not have to rename the table. So it's very useful that way. The last thing says include a totals row in your table. So we'll click back on the table or the table design tab and hit totals row. We do that, we're taken to the bottom of our data table. If you don't see the totals row, it's because your table is bigger than 49 rows. So you're going to need to go back and do it again by clicking on the contiguous data and making sure that your table stops at row 49, because otherwise your table row is going to, or your totals row is going to be way down the page and you're not going to be able to see it. But if you don't see it, try that. But most of you will see 5,136,639 and you think, what in the world is that? If you click on this drop down arrow, it tells you that that's a sum. I can change it to count the number of rows. Remember, count is going to count all of the values in this table. Remember, values are numbers. They don't include letters. If I want to count numbers, I have the same thing going on here. So it's the same formula. It's the count formula that it's doing here. Also, I want to point out that I can take the maximum value, or that's the minimum, but the maximum or the minimum value. We're going to click on average just to see what that is. And then we could average these, but again, this is divide by 0. These are all texts. We don't want to do anything with these, but we could if we wanted to, if these were more numbers. We can actually do something like count or sum these quarters. That doesn't make any sense. We wouldn't want to sum the quarters. They're qualitative data, not quantitative. So we wouldn't want to do that, but we could. Again, Excel gives us the options and we don't have to remember the formulas to do it. That's about all we've got in data tables. There's not much else to them. So we'll just move on to our lookups tab. I know that you recall from another lab how to do these lookup formulas, but I'm going to do this very quickly because you know the arguments for these functions, but I'm just very quickly going to remind you how they work. What I recommend is that you figure out where your data is. So remember, here's employee, name, favorite animal, city. We're looking for favorite animal. This is the column that we want to return on our other worksheet. We want to know the favorite animal based on someone's name. So that tells us this is in a vertical table, so we need a VLOOKUP. Later we're going to need city, also in a vertical table, and number of dependents in a horizontal table, so 2 VLOOKUPs and an HLOOKUP. Important to know which direction you're going. For favorite animal, we'll start with a VLOOKUP, and we will see our arguments once again. Lookup value. I said this last time, I'll repeat it here, just in case you've forgotten. Lookup value is whatever I'm going to use to then find the value I want to return in the other table, so in my table array. So right now I want to use the name, or I want to use Bree. I want to use the name to then find Bree's favorite animal in my table array. Also, please remember that the lookup value is going to be on the same tab where you type VLOOKUP. So when you type equals VLOOKUP, somewhere on that same sheet, on that same tab is going to be your lookup value. In this case, it's here. We'll push a comma to move to our next argument, and that's our table array. Our table array is going to be names and favorite animals. Again, remember, if you start your table array over here in employee number, it's not going to work. You have Bree, you have a name, and it must be in the leftmost column of your table array. So you're going to want to lock that in. You'll notice when I do this, I have this lookup values exclamation point syntax that's telling me the name of the tab where I'm looking up this table array. A word of caution, if I click back to the lookups table without pushing comma, you'll notice it changes to lookups. If I do that, my lookup table is now going to be here with a bunch of blank data. I don't want that. I want my lookup table to be over here on the lookup values tab, and make sure that it continues to say lookup values. Then, once I press comma, I'm able to move back and forth around to the tabs. I recommend that you stay on the tab and finish your VLOOKUP. Stay on the tab with your table array. I don't recommend that you click back on the lookups tab. It's going to put the name of the lookups tab back on there. If you click back over here, it's going to say lookups. Well, our argument here is column index number, so having the name of a sheet here doesn't make any sense. I don't want lookups. I want to know which column index. So again, it says lookup values. I don't need the table. I don't need the tab name right now. I just need the column index number. The column index number refers to which column in the table array do I want. So here I have options for column 1, options for column 2, and it says which one of these columns do you want to return. I want to see column 2. My range lookup is false because I want an exact match. I want Bree and only Bree's favorite animal. Then I just press enter. Double click and goes all the way down. If you double click and your formula goes all the way down and you have a bunch of NAs, it's because you didn't absolute reference your table array, so make sure that you know how to fix that. We'll do again city very quickly. It's VLOOKUP, open parentheses. Again, my lookup value is going to be Bree on the same tab where I am to start out with, and I'll go over to lookup values. I'm going to capture name, favorite animal, and city. Make sure that I absolute reference my lookup table. Make sure that I put a comma to change the arguments, and think to myself, I probably should stay on this tab. The rest of my arguments relate to my table array, so I'm not going to click back on the original tab. Column index number now, do I want to return column 1, column 2, or column 3? I want to return column 3 this time. And my range lookup again is false. I need an exact match to a name. Remember, the true range lookup means that I'm looking for a range of values. Last one we're going to do is an HLOOKUP, and the HLOOKUP has a lookup value just the same as a VLOOKUP, and the HLOOKUP lookup value will also be on the same tab. So again, it's Bree. Our lookup array this time is going to include all of these names as we stretch across here and absolute reference those names. Again, it doesn't matter if you include the titles or not in this particular VLOOKUP and HLOOKUP because we are using an exact match. If you are using a range lookup, however, and you include the column titles or row titles, it won't work. So beware, make sure you know what's happening. Row index number this time, this one trips people up. The row index number, because the rows are numbered, are likely to confuse you. So I don't want row 5, even though I want to return number of dependents. I don't want row 5. I want the row as it relates to my table array. So either row 1 where the names are or row 2 where the dependents are. I'll take row 2. And then I have a false match again. Again, I want Bree and only Bree's number of dependents. So there we go. A word of caution on false and true. I want you to know that if you use a range lookup, remember that your lookup values must be in alphabetical order based on the lookup value. So your names would have to be in alphabetical order, or your ranges will have to be in numerical order because the VLOOKUP and HLOOKUP only work if values are in alphabetical or numerical order. So beware as you go through that. Here's our payment tab. We have something that says today's date. Here we'll put in the today function because we know that the today function will always insert today's date. It will not insert the time. If I have date and time there, I need now in order to display a date and time. But today's date can be found by today. For a car payment, I have a 4-year loan or 48 months, $35,000, 3.75 annual interest rate. You'll notice here I have annual interest rate and terms in months, and I need monthly payments. So that makes a difference. We've done these formulas before, so again, I'm going to go at a faster pace than I normally would. But you can always rewind and rewatch me and or go back to another video if you get confused. So we're going to do negative sign, PMT for the payment function. Go ahead and put the negative sign in there because I know from past experience when I do the payment function, it's going to return a negative value, and I don't want a negative value. So I go ahead and put that negative sign in there. So for rate, I need the interest rate. Here the interest rate is 3.75. 3.75 is an annual percentage rate. I need a monthly payment. I'm going to divide that rate by 12 because there are 12 months in a year. Number of periods, I have the term in months. The term in months is what I need because I have monthly payments. If I had the term in years here, I'd have to multiply by 12 months, but I don't. I have it in months, so I'm good to go with just the number of periods. The next argument is present value. Present value is how much I still owe on this loan. So remember, it's going to be how much I still owe on this loan. So the present value minus the down payment. I'm going to take that into account. Here there is no down payment, so I'm not going to worry about that here, but I just need the amount borrowed. The last two arguments, fair value and type, are optional in Excel. We won't do those in this class. We will just do the first three arguments. The other ones are for your finance or your accounting class. So here we'll notice that this car has a monthly payment of $786. I could redo my payment function here to calculate the mortgage, or realize that all of my arguments, all of the things that I need, all of my inputs are in the same order. So I can just grab my fill handle and drag to the right and not have to put in my payment function again. I'll double click on that payment function and all of its cells will light up, and I'll go through and make sure that I have the right arguments and realize that I'm in business here. So this says, please find the monthly payment for the described car and home loan, which we just did. Additionally, please fill in the table showing what monthly payments would be based on changing borrowed amounts and interest rates. The goal here, like I said, is to enter one formula in cell F8 and then carry it down and carry it across and get all of the answers valid for this table by just entering one formula. So this requires what we call mixed referencing, not absolute and not relative, but mixed referencing. So we're going to take a shot at this now. So here we need a payment function. We know we need a negative payment function because payment functions are returned in negatives. Our rate, here we have 3.75. For this column, we have 3.75 as our interest rate. We know this is an annual rate because it begins with something that isn't a zero. And so we know it's too high to be a monthly rate. It is an annual rate. We also know it's an APR because it happens over here. It tells us it's an APR. But the question is, if I'm in this column and I drag this function down, I would want to lock this in row 7. If I drag this payment function across to G, I want the interest rate to move with me through column G. So I need to create what we call a mixed reference to freeze row 7. Now, let me walk you through the logic here. The rate is in row 7. I need, no matter where I am in this table, for my rate to be frozen in row 7, but I need it to be in the column that it relates to as I drag it across. So by freezing it in columns or in row 7, I'm effectively saying you must always stay in row 7, and where I drag you column-wise, just move column-wise, but stick in row 7, regardless of how up and down I drag you. So that's what I want to do. Again, I'm going to divide that interest rate by 12. I'm always going to divide it by 12. An annual rate converted to months is, in fact, always divided by 12. So I'm safe there. My number of payments is located in cell E7. You'll see the comment that pops up that says number of months. So that one is going to be absolute referenced. I want that number of months to be 360 no matter where I am in this table. And so I'll absolute reference that number of periods. Present value occurs in column E. So here, no matter how far I want to drag it across, I want it to remain in column E. But based on whether or not I go up or down, I want it to move to capture my present value. So by the same logic, this time I will do a mixed reference that freezes me in column E. I freeze in column E by putting the $ in front of the E, not in front of the 8, but in front of the E. So whatever you have the $ in front of is frozen, which is why when we have an absolute reference, like we do here for E7, we have a $ in both. I'm frozen in row and column, and so I want to stay in that exact cell. Again, I don't have a fair value or a type that I have to do for this class. I can just push enter. Now, 695 is the right answer. I know that because I've done this 100 times, but I could double check it, and we will in a second. I can drag that fill handle across, and I can drag it down. When I do that, I get all of these yellow things, which I don't want them to be yellow anymore. Let's go back to no fill. But I wanted to show you the formula is typed once and only once here in this cell that I'm going to turn yellow again. If I get real distracted by the fact there's no border, I can go up here and select thick outside border. It really distracts me. It probably doesn't you, which makes you a better person than me, but don't worry about it. Now, to check my answers, I'm pretty sure about this one because I typed all of these things in. I know I clicked on these. I know they're pretty accurate. So to test this, let's just randomly click on one over here. If I'm in cell J12, I need 4.25, 250,000, and 360 payments, and I know that that's right. Double click on another one just to be sure, make sure those are the 3 things that I know should be referenced, and I'm good to go. And that's all there is to this monthly payment relative referencing. Make sure that you practice it and you understand why I froze my rates in row 7 and my present values in column E, and how I froze them by putting $ in front of either the row or column. It's very important as we move forward. The last tab that we have to work with is our commissions tab. And here's what our commissions tab says. It says sales reps receive commissions based on whether or not they reach their sales goals. If reps achieve their goal, they'll receive a 7% commission. If they don't, they receive a 4% commission. So that's goal-based commission. That's what that relates to. This sentence right here, or sentences, relate to goal-based commission. I've told you in the past, and I'll tell you again, if you can do an if statement, it is much easier to do an if statement and a lot of other things that we're going to do in this class and as you continue in your information management career. A lot of things are easier if you can say them out loud. So you'll notice I walk around the class, and the GTAs do as well, and I will say, you're going to do an if statement, and you'll say, I don't know what to do. And I'll say, well, tell me in words. Forget Excel. Tell me in words what needs to happen. And you say something like, I'm trying to figure out who gets commissions. And I'll say, how do you know? How do you know who gets commissions? And you'll say, if they meet their sales goal, they get 7%. And that's exactly right. That's what we're going to do. So we're going to do equals if their actual sales are greater than or equal to their sales goal. So if they meet their sales goal, if they meet or exceed their sales goal, if their actual sales are greater than or equal to their goal, what happens if that's true? If that's true, we have 0.07, which is 7%, times their actual sales. Commissions are paid to sales reps based on what their actual sales are. This is standard business logic and something that I would expect you all to be able to figure out. I will do my best to make it clear in other situations where you are not getting help what the business logic is. But as we move forward, I'm going to expect you to know things that we've covered in class. So this is one that I would expect you to know. I would expect you to know that commissions are paid on actual sales. We've talked about it. We've done it. So I expect you to be able to reproduce it. If their actual sales is not bigger than their goal, however, they get 4%, which is 0.04, times their actual sales. And close our if statement, and we get 7280. The next one says they have a tenured-based commission. It says, additionally, sales reps will receive a bonus commission of 2% if they've been employed for 10 years. Regardless of whether the goal is met, please calculate the total commissions for each sales rep. So here I have another if statement that says people who've been here 10 years or more are going to get 2% commission. So how do I know if somebody's been here 10 years? 10 years from what? 10 years from next week, 10 years from last month, 10 years from January 1st, or 10 years from today. Most of you would say 10 years from today. There are a variety of ways to do this. I'm going to show you the way that I would do it with a nested function. So if today, so that's going to give me, I can insert this function today, which has no argument. So if I just type today and I open the parentheses, you'll see the today function has no arguments. You can double click on that and it'll tell you. Or you can just close the parentheses. You should know that today doesn't have any arguments. We've used that several times in this class, so you should know. But if today, because today is a numerical value to Excel, minus this person's hire date, which should be before today, so we should come out with a positive number. If today minus this is greater than or equal to 10 years, right? So we're looking for 10 years. So here we have to know that today minus the hire date is going to give us the number of days between today and their hire date. It's going to give us the number of days. So we're going to take 10 years and multiply it by 365 days. So if today minus their hire date, if they've been here for more than or equal to 10 years consisting of 365 days, if that's true, they're going to get 2% times their actual sales goal. If not, they're going to get 0. So I can take this and I can drag this down and realize that these two people, Jones and Fry, have not been here 10 years. They should get 0. So that's how that should work, and it does. But I want to show you another way. So there's another way that you could get this. Like you could go up here and you could put today in this cell up here. So how about if I do equals if, and now I can click on today minus the hire date, but I need to make sure that I freeze or absolute reference today minus the hire date is greater than or equal to 3,650, which is 10 years times 365 days. If that's true, I need this person to get 0.02 times their actual sales. If that's not true, I need them to get 0. This one should return 0, and it does. It also returns the correct values as we go down. So as you can see, there's a variety of ways to get there. Later in the class, we're going to learn different functions that'll calculate it for us. We're going to learn year frac. We're going to learn days between. We're going to learn things like that. So we could use a variety of options to be able to get us to this answer. Your logic is what matters. When I'm grading your exams and I'm grading your projects, I'm going to be looking for the logic. Are you able to reasonably come up with an answer that would let me know that you understand what's happening both in Excel and in the business problem? So it's important that you know this is calculating days between these two dates. And it's important that you understand the greater than or the equal to logic. All of those things are important. Lastly, it says calculate their total commission. Guys, this is just a sum of these two numbers. It's really easy. You put a sum and you highlight the two numbers to the right. You can also do this one plus this one. I don't care how you get there, just care that you do it. The last one says conditionally format all sales reps that receive more than $12,000 in commission. Format the entire row in yellow fill. So here we go. In order to create an entire row of conditional formatting, the easiest thing to do is select all of these columns. And we're going to go to conditional formatting. We're going to say I want to apply a new rule. When I have more than one column, I can't just do these top and bottom, these given functions. I have to do a formula. So I have a new rule. If I'm on a PC, this is real easy. You use a formula to calculate. But here on a Mac, I have to go to Classic, and I have to go to use a formula to determine which cells to format. Here, I have to type in a formula that says that column G is greater than $12,000. And I need to know, is it greater than $12,000? So here, what I need to do is I need to type equals, and then I notice that my active cell is A1. I know my active cell is A1 because if I look, it's highlighted in white here. Before I did my equal sign, it said A1 right here in this space right here, but it goes away once I push the equal sign. So I need to make sure that I'm looking at cell G1 because that's in the same row with my active cell. That matters because I don't want to be off kilter. It's going to mess up all of my highlighting. If G1 is greater than 12,000, I want you to do a custom format, and I want you to tell me that it's got a background fill of yellow. Again, that's much easier to get to on a PC, but we'll do it from there. So one thing I want to point out, I want this formula to always look in column G. I do not want it to always look in row 1, so I'm going to delete that $ in front of the 1 and capture always in column G 1. And click OK, and it's going to highlight all of the ones that are above 12,000 for me. You'll notice it also highlights my top column headers. I don't want it to do that. So I go back to conditional formatting, and I'm going to highlight my column headers, and I'm going to say conditional formatting, clear rules from selected cells, and it'll get rid of my highlighting. I can't just highlight them and make them white again. Conditional formatting freezes them in the color that I have told it. Hopefully this helps you with Chapter 4 and Chapter 9. Hopefully you're starting to see how all of this is falling together and how it's going to make your life easier when you leave the University of Tennessee, and how you're going to be able to solve these problems based on what you know. So hopefully you're getting a lot out of it. Please let me know if you have questions.